Hi guys, in this class I would like to discuss common forces in mechanics. So far we learned some forces from the elementary knowledge. So the first force, what we know that if I take an example at here, suppose this is a situation, some weight is kept on the bench, on a table. So gravity is existing. So because of the gravity, there is a force, so which is acting, that is downward direction. So this is the gravity which is acting on the object in downward direction. So because of the gravity and here the object having mass, so there is a force which is acting downward direction. So that force we can write that F equal to mg. So this force only we call as weight. Yeah, weight is a force. Weight is a force. It's not measure of a mass. Don't be confused that. So the first force we know about weight. So its formula goes to weight equal to mg. M equal to mass of object and g is the acceleration due to gravity. And think about that. We know the Newton's third law. What is the Newton's third law? For every action there is an equal and opposite reaction. Now if a force which is acting downward direction and this object is at rest, if this object is at rest, there is some other force which should be balanced. So in the same magnitude but opposite in direction. So we know that downward direction, the force which is acting, so this is the gravity. The gravity causes a force which is known as weight. So here the weight is a force which is acting downward direction, W equal to, which is acting downward direction. To balance this force, we take one more force which is known as normal reaction force. Normal reaction force or simply normal force, we can represent that with capital N. So if N is a normal reaction force, so what is the value of N at here? Since in this case the object is at rest, so both the forces are balanced. So now we can write that if W is the weight is acting downward direction, so normal force acting upward direction, the magnitude of normal force equal to mg. But when it comes to direction, we need to represent the direction the opposite to the weight direction. So whichever the case is, you need to write about the normal force if the object is at rest. So this is something new for us, normal reaction force, which always acts on any object to counterbalance the weight on the object. So this is second force which is known as normal reaction force. And the third force, so which is something we know that, so the third force I can take that friction. Yeah, we studied much more about the friction. So between the objects and the surface there is a force of friction. The friction always acts. So the friction is third force which is acting in the mechanics. And when it comes to fourth one, so this is acts in springs. Suppose this is a situation, I am having a spring balance of weight. Now here, if you can weight an object, so this object mass and gravity will be gives the weight of the object. Now weight is a force which is acting downward direction. So counterbalance this weight, and here this weight is kept in a pan. So this pan is attached to a spring. Now there is a force which is acts in the spring to counterbalance the weight. So that force we know as spring force. So this is the next force if we can take. So I can talk much about when the right situation comes. So we will talk while discussing about the springs and all. So this is the next force I can take. Spring force. Now let me take one more case. So in this case, suppose this is the case. So what are the forces which are acting right now in this given figure? Now if you mention right now here the weight is a force which is acting downward direction. So that is the force weight equal to, so I can write that F equal to mg. So this is a force. So counterbalance at here, there is a force which is acting in upward direction. You should be straight. So this force we call as a normal reaction force. So this is normal reaction force. Suppose if I take a friction, so friction force is acting opposite direction. So this is a friction. And at block B here you can see, so this is weight which is acting downward direction mg, and this block is connected to a string or a rope. So this rope is balancing the weight which is connected at here. So the force which is acting in the string or rope we call as the tension. So here the force which presents in connected mass is known as tension. So here since the block is at rest, we can make it equal tension equal to mg, because these two forces are equal but tension is acting in the opposite direction. In the same case here also if you can see, since the block is at rest, normal reaction force balances with weight and the friction force should balances with the tension in the string. Then only the object will be at rest. Since all forces should be balanced. So this is the another force which I include to our list. A part of the spring force we can add tension. So these are the forces right now we need to know. First one is weight. Weight is a force. Second one is normal reaction force. The normal reaction always acts on the object to counterbalance the weight. And the next one is friction. Friction is a force which comes between the two surfaces. And when you take consideration the springs, so that force known as spring force. But when you tie up with a rope or thread, so there is one more force which comes, so that force known as tension. So these are the common forces so far. So we will deal in this chapter. A part of the common forces in the mechanics, So we need to solve problems which involves Newton's laws and force. To solve the problems, it is very important to draw a diagram which shows all the forces acting on each object involved. So the diagrammatic representation of the force which is very helpful for us to solve the realistic problems. Now such diagrams we call as free body diagrams or force diagrams. So free body diagrams help us to solve the resultant force. And whatever situation is given, if you draw a proper free body diagram, so that free body diagrams leads us to a very good result and easy result. And for that, we need to follow certain rules, not very big and complicated. First one, we need to choose one object, in which object we are going to find the resultant force. Okay, choose one object and draw an arrow to represent each force acting on it. Each force. So whatever the forces we are including, so those forces we need to represent in an arrow mark. Let me take an example. Suppose this is an example. A block of mass m at rest. So this is at rest. So I need to represent this in free body diagram. So if I draw free body diagram, we need to represent the forces which are acting on this object. Since the block is at rest, we consider there are the two forces which are balancing. One is weight, which is acting downward direction. To counterbalance this weight, normal reaction force which is acting in the upward direction. So that's it. So this is a way to represent free body diagram for this case. Let me take one complicated situation. Suppose if this is the situation, a block of mass m which is moving towards to the right direction. In this direction, the object is moving by applying a force. Now the block is at rest, or it is moving forward. It's not at rest. Here the velocity is represented. It means it is moving towards to the east direction. This is east direction. Now since it is moving towards to the east direction, first let us try to draw the free body diagrams. As usual, we need to draw the two things. One is the normal reaction force, which counterbalances with the weight. Okay, these two forces are balanced. So that's why the object is not moving up and down. Now the object is moving east direction or to my right direction. So because in that direction force is more. This is common sense. In which direction force is more? In that direction object moves. So it means in the right side direction force is more. So to counterbalance, there is a force friction which is acting between these two surfaces. Here the friction force is less than the applied force. So that's the reason the object is moving forward direction. So if I draw for this free body diagram, the case object moving forward. object moving, forward direction, free body diagram. So this is how we draw free body diagrams. So let me take one case to draw the free body diagram. Now this is the case. We need to draw free body diagram in this case. Now here you can see these objects are connected to a pulley. So this is known as pulley, are connected to two strings, and these two blocks are at rest. They are not moving. And don't think that how it is 3.2, 1.2 for a moment. So let me take this as 3.2. Now just I want to draw the represent the free body diagram. I know that weight is a force which is acting downward direction. So weight is mg on this block. So to counterbalance weight, there is a force which is acting in upward direction, that is tension. In the same way, in the another downward direction, weight mg which is acting downward direction, and to counterbalance upward, tension is acting. So this is all about free body diagrams, which is easy. So let me make little more complicated. Suppose if I take a case, now let us try to draw a free body diagram for this given case. Yeah, let's try to draw the free body diagram for this case. So you can see here the A and B are the two different objects. If two objects are there, we need to draw separately for two different free body diagrams. Now first we can see in which direction the objects are moving. So they are at rest. So first I will draw for A object. So the weight is acting downward direction. So this is mg. So the opposite direction, to counterbalance normal reaction force, is acting upward direction. And you can consider friction. So if you can take friction little f, friction force which is acting at here, and to counterbalance in the forward direction in the string, what is the force acting? Tension which is acting in the forward direction. So this is the free body diagram for object A. It's very simple. And we will draw the free body diagram for object B. I will draw it down. So the weight which is acting downward direction, so which is mg. So to counterbalance weight, there is an upward direction which is tension which is acting in the upward direction. So this is how simple it is to represent the sum of the forces for a given case. So that is, we call it as free body diagrams. Now if I show the free body diagrams for this case, so this is the exact representation of free body diagrams. Now let me take one more case. In this case I would like to make the things complicated. Suppose if I take this as draw the free body diagram for the force which is acting on the sledge. Now what are the forces which is acting on this sledge, or the boy who sat on the sledge? Now there is a force which is applying from the backward direction. So they already represent the force direction at here. So a part of that we need to draw our regular force. So what was that? Weight which is acts downward direction mg. So to balance the weight upward, one force will becomes always, so that force is normal action force. And in this situation, a part of these two forces, a friction force. We cannot forget that friction force, the friction force which is acts between the surfaces of the sludge and the bottom surface. Now if I can show the free body diagram for this, in this case, so this is the free body diagram which is acting on the object which is present on the sledge. So that object we consider as a point object. So that point you can keep in mind. So on which object the forces are we are going to find, so that object we should consider as point object. Now let me take one more example. Now what are the forces which are acting on the boy who sat on the sledge? So first we take the boy as a point object. So on the boy is applying a force in this along this direction. We should not change the direction, that is the force direction. Otherwise if you want to take help of reference line, so this is the reference line, you can take that help. So this is the applied force which is applied. And a part of that, two common forces, one is the weight which is acting downward direction which is mg, and one is upward force, here it is normal action force. So n is normal action force. So if I represent the same forces at here, so n will be acting upward direction. With the same magnitude, the downward direction weight will be act. Weight is the downward direction and normal action force upward direction. And obviously we should not forget to draw the friction. The friction force which is acting opposite to the applied force direction. Now if I draw the friction force at here, so this is the friction force direction. So this is friction. So these are the total forces which are acting on the boy who sat on the sledge. So this is how we represent free body diagrams.